Before we begin, take a moment to settle in. Find a comfortable place to rest, letting your body soften and your breathing slow. There's nothing you need to focus on, and nowhere you need to go. This is simply time set aside to be still, to listen, and to let the pace of the universe carry you gently forward. As this story unfolds, you're welcome to stay awake, to drift, or to fall asleep entirely. Everything will continue quietly, whether you're listening closely or resting deeply. Feel free to comment where you're tuning in from. When you're ready, let the light fade a little, and we'll begin. Chapter 1. When Heat Was Young. In the quiet moments before sleep, warmth is often one of the last sensations we notice. The gentle heaviness of a blanket, the slow cooling of the air in a darkened room. Heat is familiar, intimate, and immediate. It moves without asking for attention, flowing softly from one place to another, easing differences until everything feels even and calm. At its most basic level, heat is motion. It is the subtle vibration of atoms and molecules, the small, restless movements that never fully stop. Even in stillness, even in apparent silence, matter is gently trembling. When something is warm, its particles move a little faster. When it cools, they slow. And always, without exception, that motion spreads outward, drifting from warmer regions into cooler ones. This simple tendency governs everything, from a cooling cup of tea to the vast architecture of the universe itself. Long before there were stars, planets, or even atoms as we know them, the universe was defined by heat. In its earliest moments, energy was packed tightly into a small, dense space. Temperatures were unimaginably high, and differences from place to place were extreme. Nothing resembling structure could exist yet. There was only motion, pressure, and an intense brightness filling every direction. As the universe expanded, it began to cool, not suddenly and not violently, but steadily. Space stretched, giving energy more room to spread. With each passing moment, temperature differences softened just enough to allow the first simple particles to form. Quarks settled into protons and neutrons. Electrons found places to linger. Eventually, atoms emerged, drifting in a growing sea of space. This cooling was not an ending, it was a beginning. Heat, after all, does not disappear. It moves, it redistributes, it flows from concentration toward balance. And in doing so, it allows complexity to arise. In the young universe, heat was unevenly distributed. Some regions were slightly denser than others, just by chance. These small differences mattered. Where matter gathered, gravity gently amplified the imbalance, pulling more material inward. As gas clouds grew denser, pressure and temperature rose again, reigniting pockets of warmth within an overall cooling cosmos. These were the seeds of the first stars. A star is, at its heart, a negotiation between heat and gravity. Gravity pulls matter inward, compressing gas and raising its temperature. Heat pushes outward, resisting collapse. For long stretches of time, these forces balance each other, creating a steady glow that can last billions of years. In this way, the universe learned how to localize heat. Surrounded by vast regions of cold, stars became islands of warmth. They did not halt the overall cooling of the universe, but they slowed it locally, creating gradients, differences in temperature that allowed light, chemistry, and eventually life to exist. Every star that has ever shone is a temporary interruption in the universe's long journey toward equilibrium. Even today, long after the universe's fiery beginnings, traces of that early heat remain. They drift quietly through space as the cosmic microwave background, a faint, uniform glow that fills all directions. This radiation is not light we can see with our eyes, but it carries the memory of a time when the universe itself was warm enough to glow. Now, that glow is barely above absolute zero. It is gentle, even, and nearly the same everywhere. A whisper of warmth, stretched thin by expansion. The universe continues to expand still. With every passing moment, galaxies move farther apart, and energy spreads over larger volumes of space. This expansion does not require effort. It does not rush. It simply continues, carrying heat along with it, smoothing differences as it goes. And yet, the universe is far from finished with its story. Around us, stars are still burning. Galaxies still shine. Planets still orbit warm suns. Heat still flows, creating winds, oceans, and weather. These processes feel active, even energetic, but they are all part of a broader trend, the gradual evening out of energy. Where there is warmth, it leaks into cold. Where there is motion, it spreads. Where there is contrast, it softens. This tendency is known as entropy, though it does not need a name to be felt. It is the reason warmth fades from our hands in winter air, the reason rooms cool after heaters turn off, the reason differences rarely sharpen on their own. Entropy is not disorder, it is distribution. In the early universe, energy was highly concentrated. Over time, it has been spreading, becoming more evenly shared among particles and across space. This spreading allows change to happen at first, but it also sets gentle limits. The more evenly energy is distributed, the harder it becomes to extract motion, work, or light from it. In a sense, the universe began its life rich in contrasts. Hot and dense regions stood beside cooler, emptier ones. These contrasts powered everything that followed. But contrasts do not last forever. As expansion continues, and as heat continues to flow, the universe slowly moves toward balance. Not a sudden balance, not a final one, just a gradual softening of extremes. This is not something to fear. It is simply the nature of energy moving through space and time. The universe is still young in this process. Heat is still uneven. Stars still blaze. But the direction is set. Energy will continue to spread, becoming harder to gather, harder to focus. In the chapters ahead, the story will slow further. The stars will enter a long evening. Light will become rarer. Motion will quiet. For now, though, we remain in an era where warmth still gathers, where night skies glow, and where heat, once wild and overwhelming, has learned to burn gently, patiently, in scattered points of light across a cooling cosmos. And as the universe drifts forward, so too can the mind, settling into rest, carried by the same quiet rules that guide stars and space alike. As heat learned to move more freely, it also learned how to shape structure. The early universe was not perfectly smooth. Tiny variations in density, smaller than anything that could be felt, became invitations for gravity to act. Where matter gathered just a little more tightly, warmth followed, motion increased, pressure rose. And slowly, almost imperceptibly, the universe began to differentiate itself. These differences were fragile. They existed against a background that was always trying to even itself out. Heat flowed outward from dense regions, and expansion stretched matter thinner. Yet gravity worked patiently, pulling inward over immense spans of time. The balance between these tendencies, spreading and gathering, became one of the defining rhythms of the cosmos. Within vast clouds of hydrogen and helium, gravity continued its quiet work. As atoms drifted closer together, collisions became more frequent. Each collision transferred energy, raising temperature bit by bit. Over millions of years, some regions grew hot enough for nuclear fusion to begin. In these places, hydrogen atoms merged into helium, releasing energy in the process. This release of energy was not explosive. It was controlled, sustained, and self-regulating. Heat pushed outward, preventing further collapse, while gravity pulled inward, maintaining pressure. A star was born not in violence, but in balance. With stars came light, photons carrying energy across space. Light itself is a form of heat in motion, traveling vast distances without tiring. Each ray that leaves a star spreads energy outward, contributing to the slow redistribution that defines the universe's long trajectory. Every beam of starlight is part of this story. It warms nearby dust. It drives chemical reactions. It illuminates planets. And eventually, after traveling through space for thousands or millions of years, it fades into the background, its energy diluted, shared, and softened. The early universe was rich with these exchanges. Heat moved constantly between matter and radiation, between dense regions and open space. Nothing was isolated. Everything participated in the gradual smoothing of differences. Even the formation of planets followed this rule. Around young stars, disks of gas and dust absorbed heat, radiated it away, and slowly cooled. Particles stuck together more easily as motion slowed, allowing grains to grow into rocks and rocks into worlds. Cooling made solidity possible. Without the gradual loss of heat, nothing firm could exist. In this way, the universe's tendency to spread energy did not prevent complexity. It enabled it, temporarily. But every structure built on heat differences carries an expiration. Stars shine because their cores are far hotter than the space around them. Planets remain warm inside because their interiors differ from their surfaces. Life itself depends on gradients between sunlight and shadow, warmth and cold, chemical concentration and scarcity. As long as these differences exist, processes continue. Motion persists. Time feels active. The early universe had differences everywhere. Heat was abundant and uneven, flowing rapidly, driving constant change. Over time, as expansion continued and energy spread more evenly, those differences became harder to maintain. New stars still formed, but more slowly. Matter had farther to travel. Gas clouds were less dense. The universe was learning how to rest. This resting is not an event. It is a direction. Even now, the cosmos carries far more usable energy than it will in the distant future. Heat still gathers in stars. Galaxies still collide and merge, briefly reigniting warmth through motion and compression. Yet each interaction also disperses energy, sending it outward, thinning it across ever larger volumes of space. Nothing resists this forever. Entropy continues its quiet guidance, not as a force, but as a tendency. Energy spreads because there are more ways for it to be spread than to be concentrated. Balance is statistically favored. Uniformity is the most likely outcome when time is long enough. In the youth of the universe, time had barely begun its work. Heat was young, lively, and sharply divided. That youth gave rise to stars, planets, and complexity. As the universe moves forward, that youthful unevenness slowly softens. The differences that once powered creation begin to fade, not abruptly, but with patience measured in billions of years. This chapter is only the beginning of that long evening. For now, warmth still flickers across the cosmos. Light still travels. Motion still matters. The universe has not grown quiet yet, but the path ahead is clear, and it is gentle. In the next chapter, the story will linger among the stars themselves, following their slow burning, their gradual dimming, and the way even the brightest lights eventually give way to softer, quieter states. And as this warmth-filled beginning settles, the mind can settle too, drifting alongside a universe that has always known how to move from motion toward rest. As the universe continued to cool, it did not do so evenly. Some regions lost heat more quickly, while others held onto it longer. These subtle delays mattered. Cooling slowed motion, and slower motion allowed particles to linger near one another. Where particles lingered, interactions became possible. Chemistry emerged quietly, guided by temperature and time. In warmer regions, atoms moved too quickly to remain bound for long. Bonds broke as fast as they formed. But as space expanded and temperatures eased, electrons began to settle into stable orbits around nuclei. Molecules formed, fragile at first, then increasingly persistent. Each new bond represented a small pocket of order, made possible by the gentle loss of heat. This pattern repeated on larger and larger scales. Cooling gas clouds became nurseries for stars. Cooling disks became foundations for planets. Cooling planetary surfaces became places where complex chemistry could unfold. None of this required intention or design. It followed naturally from heat spreading out. Light played a quiet but central role in this process. Every photon carries energy, and every photon that escapes a hot region helps cool it. Stars shine because they lose heat. Their brightness is not excess, but release. Without this steady outward flow of energy, stars would not remain stable. They would collapse inward or flare uncontrollably. Instead, they glow calmly, shedding warmth into surrounding space. That warmth does not vanish. It travels. It encounters dust and gas, gently warming it before moving on. Over time, light stretches as space expands, its energy thinning, its color shifting toward longer, softer wavelengths. What begins as brilliant starlight eventually becomes faint background radiation, blending into the cosmic quiet. This stretching of light is another way heat learns to rest. Energy remains, but it becomes harder to gather, harder to focus. Throughout this early era, the universe was filled with motion, but it was motion with direction. Heat flowed outward, differences softened, yet enough imbalance remained to sustain change. Galaxies began to assemble, not as single events, but as long processes. Smaller groups merged, their motions converting into heat, briefly raising temperatures before dispersing again. Each merger was a redistribution, not a reset. Within galaxies, stars lived out their long, steady lives. Some burned quickly and brightly, exhausting their fuel in millions of years. Others burned slowly, conserving their warmth for spans of time far longer than the current age of the universe. Together, they formed a spectrum of heat release, from brief flares to enduring glows. This diversity mattered. It ensured that warmth would be available across many eras, not all at once. The universe learned how to pace itself. As stars formed and shone, space between them continued to cool. Vast regions grew darker and colder, while isolated pockets remained warm. This contrast defined the era we inhabit, a universe where islands of activity float in an ocean of cold. It is easy to mistake this for permanence. The night sky feels stable. Stars seem fixed. But stability here is only temporary. Balance. Over immense stretches of time, even the most enduring stars change. Their cores slowly alter as fuel is consumed. Their outer layers respond, expanding or contracting. Heat moves outward, always outward, guided by the same quiet rules that shaped the early universe. Entropy does not rush these changes. It allows them to unfold at their own pace. Given enough time, every concentrated source of heat relaxes. The universe does not lose energy as it ages. It loses contrast. This distinction matters. Energy remains present even in the far future. What fades is the ability to use that energy to drive change. Without temperature differences, motion stalls. Without gradients, processes slow. In the early universe, gradients were everywhere. That abundance gave rise to motion, structure, and complexity. As those gradients soften, the universe gently shifts toward stillness. This shift is gradual beyond ordinary comprehension. It spans timescales so long that familiar units lose meaning. Billions of years become brief chapters. Trillions become natural extensions. Against such time, urgency dissolves. Chapter 1 lingers here, in the warmth of beginnings, where heat was plentiful and differences were strong enough to shape everything that followed. The universe was not rushing toward an end. It was exploring possibilities made available by imbalance. Those possibilities are still unfolding around us. Every star overhead is a reminder of that early warmth, still burning, still releasing energy into the dark. Yet even as we rest beneath those stars, the same gentle trend continues. Heat spreads, differences soften, motion eases. This is the rhythm that carries the universe forward, quiet, patient, and unbroken. In time, this rhythm will carry us into the long evening of the stars, where light grows rarer and warmth lingers longer in fewer places. For now, the universe remains softly lit, its youthful heat still echoing through space, inviting rest, reflection, and calm. In the quiet of deep time, the universe learned patience. Heat, once compressed and intense, now moved with greater freedom, taking longer paths, encountering fewer obstacles. As space grew larger, energy had more room to wander. Each expansion gave warmth a wider landscape in which to disperse. This wandering of energy did not erase structure immediately. Instead, it stretched the intervals between events. Reactions slowed. Encounters became rarer. Where early particles collided constantly, later ones drifted for long periods before meeting again. Time itself seemed to open, allowing processes to unfold without urgency. In this spaciousness, the universe became more subtle. Change still occurred, but gently. A star might shine for billions of years without dramatic variation. A planet might orbit in quiet regularity, its internal heat slowly leaking into space. Nothing demanded haste. Even within stars, the movement of heat followed careful paths. Energy generated in the core did not rush outward. It took thousands, sometimes millions of years to reach the surface, passed along through countless interactions. By the time it escaped as light, it had been shared, moderated, and softened. This slow journey mirrors the universe itself. What begins concentrated and intense gradually becomes diffuse and calm. As galaxies matured, their internal motions eased. Early collisions gave way to more settled orbits. Star formation slowed as gas was consumed or scattered. The brightest eras passed quietly, without announcement. The night sky we see today is already gentler than it once was. There are fewer newborn stars now than in the universe's earlier chapters. The overall glow has dimmed, though not enough to be noticed on human timescales. This dimming is not failure. It is completion of a phase. Every system that relies on heat differences follows a similar arc. Activity peaks when contrasts are strong, then tapers as balance approaches. The universe is no exception. Entropy ensures that no process can repeat indefinitely. Each cycle spreads energy a little further, smoothing differences a little more. Over time, the cost of motion increases, and the return diminishes. Yet this gradual loss of efficiency is also what grants stability. Without it, systems would remain volatile, never settling into lasting forms. The universe's willingness to relax is what allowed it to build anything at all. Cooling does not mean emptiness. It means gentler motion. Even in the coldest regions of space, particles drift. Radiation persists. Time continues. In the early universe, heat drove rapid transformation. In the present era, it supports slow continuity. In the far future, it will allow rest. Chapter 1 rests here, at the threshold between youth and maturity. Heat has done its most dramatic work, shaping stars and galaxies, but it has not yet faded into uniform quiet. The universe remains active, though its pace has softened. Light still crosses vast distances. Warmth still gathers in isolated places. Motion still matters. As this chapter draws to a close, the direction ahead becomes clearer. The stars will carry the remaining contrasts forward, releasing their heat over immense spans of time. They will become the final stewards of warmth in an ever-expanding cosmos. And beyond them, stillness waits, not as an ending, but as a continuation of the same gentle rules. For now, the universe lingers in a long afternoon of light, warm enough for complexity, calm enough for rest. It is here that Chapter 1 settles, inviting the mind to do the same, easing into the knowledge that even the grandest motions follow quiet paths toward balance. As the universe aged, its changes became quieter, but no less meaningful. Where once heat surged and transformed matter rapidly, it now worked more slowly, guiding systems toward steadiness rather than upheaval. This slowing was not imposed from outside. It arose naturally as energy spread across greater distances and thinner regions of space. In these later stages of cosmic youth, vast emptiness became the dominant feature. Between galaxies, space grew colder and darker, stretching the paths that heat and light had to travel. Photons wandered longer before encountering matter, and many traveled endlessly without meeting anything at all. Their energy still existed, but it was no longer shaping structures nearby. This growing separation softened interactions everywhere. Gravitational encounters still occurred, but less often. Gas clouds still collapsed into stars, but with increasing rarity. Each new star became more precious, not because it was fragile, but because it was less easily replaced. The universe had entered a phase where creation continued, but at a gentler pace. Within galaxies, the balance between heat and gravity maintained a long calm. Stars traced predictable paths. Their light warmed surrounding dust, which glowed faintly before releasing that warmth back into space. Over and over, energy passed from concentration to diffusion, from brightness to background. This repeated sharing of heat created a sense of continuity. Nothing ended abruptly. Everything faded gradually. Planets, too, participated in this long release. Formed hot and molten, they cooled over billions of years. Their surfaces hardened. Their interiors retained warmth, which leaked outward slowly, powering geological motion for a time. Volcanoes erupted, continents drifted, and then, eventually, these motions eased as internal heat diminished. Even here, the pattern held. Heat enabled change, then quietly stepped aside. On some worlds, cooling created stable environments where chemistry could linger. Oceans formed as temperatures settled. Atmospheres developed as gases slowed enough to remain bound. These conditions were temporary gifts of imbalance, allowed by the universe's youth. But the universe did not single out any planet for permanence. The same rules applied everywhere. Heat flowed outward. Differences softened. Equilibrium approached. Entropy remained constant in its direction, though invisible in its action. It did not dictate how quickly systems changed, only that they would not reverse their spreading of energy. What cooled would not spontaneously grow hotter. What dispersed would not gather itself without effort. Effort, in cosmic terms, always required contrast. And contrast over time became harder to maintain. As this chapter lingers, it does so in a universe still rich with variation. Stars of many sizes burn at different rates. Galaxies glow with uneven brightness. Space holds pockets of warmth amid vast cold. These differences sustain motion and meaning. Yet beneath all activity lies the same quiet tendency, guiding energy toward rest. The early universe once rushed with transformation. Now it breathes slowly, expanding, cooling, and smoothing. The intensity of youth has given way to endurance. This endurance will carry the cosmos far beyond the present moment. It will support stars that burn for trillions of years, and planets that orbit in darkness long after their suns have faded from view. But endurance is not permanence. It is simply slowness. As Chapter 1 continues to unfold, it remains grounded in this truth. The universe began warm and uneven, and from that unevenness arose everything familiar. Heat was the first guide, shaping matter through motion and difference. The same heat now prepares the way for quiet. Soon, the story will turn fully toward the stars themselves, tracing their long, patient lives as they release the last concentrated warmth the universe will ever know. For now, this chapter remains in the glow of beginnings, where heat was young, abundant, and generous enough to give rise to light, structure, and time itself. Here, in this lingering warmth, the mind may rest, knowing that even the universe learned to slow down. As time continued to open outward, the universe became defined less by events and more by intervals. The spaces between changes grew longer. The pauses deepened. Heat still moved, but it did so across distances that were steadily increasing, taking longer to make its presence felt. In this widening quiet, the cosmos developed a kind of patience. Stars no longer formed in great waves, but individually, separated by long stretches of stillness. Each new ignition was the result of countless small motions, aligning just enough, for just long enough, to allow gravity and heat to meet once more. When such moments occurred, they felt almost ceremonial in their rarity. A cloud would slowly contract, temperature would rise, fusion would begin, light would emerge again, steady and unhurried, adding its warmth to the vastness around it. Most of the universe, however, remained dark and cold, content to drift. This contrast between scattered warmth and surrounding coolness defined the era. Heat had become precious, not because it was scarce in absolute terms, but because it was no longer concentrated. Energy existed everywhere, yet usable warmth gathered only in a few places at a time. The universe did not mind this change. It simply followed it. Within galaxies, older stars outnumbered younger ones. Their light carried the memory of earlier conditions, when gas was more abundant and collapse more common. As these stars aged, their internal processes adjusted, but always with restraint. Changes unfolded slowly, allowing long periods of relative calm. The sky, from any single vantage point, would have appeared stable for immense spans of time. Constellations held their shapes. Orbits repeated without deviation. Heat flowed steadily, predictably, without surprise. This predictability was itself a sign of aging. Entropy does not announce itself with drama. It is most evident where nothing seems to happen. When systems stop changing quickly, when motion becomes regular and subdued, energy has already spread far from its origins. Even explosions in this era were quiet by cosmic standards. When massive stars reached the ends of their lives, The energy released dispersed into vast surroundings, seeding space with heavier elements, but also thinning itself in the process. Each such event increased the universe's chemical richness while further diffusing its heat. Creation and cooling continued hand in hand. As matter grew more complex, it also grew more isolated. Elements forged in stars drifted through space, sometimes finding new homes, sometimes wandering alone. Their journeys were long, their interactions infrequent. Heat accompanied them only faintly. The universe was no longer a place of constant contact. It had become a place of long separations. These separations changed the meaning of warmth. No longer a pervasive background, heat became something localized and temporary. A star shone for its allotted time, then passed its remaining energy outward and onward. Nothing reclaimed that energy. It simply joined the wider flow, indistinguishable from countless other contributions. This is how the universe remembers, not through preservation, but through accumulation. Every release of heat adds to a growing background, a shared reservoir of motion, too evenly distributed to drive new events easily. Over time, this background grows richer, even as individual sources fade. Chapter 1 now dwells in this mature calm, where the universe has settled into rhythms that favor duration over drama. Heat still matters, but its influence is subtle. Differences persist, but they are no longer sharp. From this point forward, the story will narrow its focus, turning toward the few remaining places where warmth still gathers strongly enough to shape the future. Those places are the stars. They will burn slowly. They will release their energy carefully, and they will do so in a universe increasingly prepared to receive that energy and let it rest. Here, at the close of this chapter, the cosmos feels neither young nor old, but balanced between motion and stillness. Heat has done its formative work. The next phase will be about endurance, patience, and the long, quiet letting go of light. As the universe continues onward, so can the mind, settling into the understanding that even change itself eventually learns how to be gentle. As the universe lingered in this balance, its vastness became increasingly apparent. Distance itself grew into a defining feature. Between sources of warmth lay enormous regions where very little happened at all. In these stretches, space carried only the faintest traces of energy, drifting without direction, unhurried and unclaimed. In such places, time felt almost suspended. Without strong gradients to drive change, moments blended into one another. Motion persisted, but it was minimal, more a gentle drift than a purposeful journey. Heat existed here, not as warmth that could be felt, but as a background presence, evenly shared and largely inactive. This evenness was not empty. It was simply calm. From time to time, a photon would pass through these quiet regions, carrying energy from a distant star. It would travel for thousands, sometimes millions of years, without touching anything. When it did encounter matter, the exchange was subtle, a slight warming, a brief interaction, before the energy continued on its way, further diluted by expansion. These long journeys illustrate how thoroughly heat had learned to spread. What once surged outward in every direction now wandered patiently through immense volumes of space. Within galaxies, the contrast between warmth and cold remained, but it softened with age. Stellar neighborhoods became more stable, less crowded, less prone to dramatic change. The universe favored longevity over intensity. This preference shaped everything that followed. Systems that could endure with minimal energy thrived. Those that required sharp contrasts faded sooner. Over time, the cosmos selected for gentleness. Even gravity, though relentless, worked within these constraints. It gathered matter where it could, but without abundant heat to counterbalance it, structures became simpler. Large-scale motions slowed, orbits settled. The grand dynamism of earlier epochs gave way to a quieter choreography. Throughout all of this, the same rule held. Energy moved from where it was concentrated to where it was not. Each transfer reduced contrast, even as it increased the total background of shared motion. This shared background grew steadily richer, though it remained faint. It did not announce itself. It simply accumulated. As Chapter 1 nears its close, it does so in a universe that has learned how to wait. Heat is no longer young and exuberant, but it is not gone. It persists everywhere, spread thin, guiding the cosmos toward balance one gentle step at a time. The stage is now set for the next part of the story. The remaining differences in temperature, pressure, and energy are increasingly concentrated in fewer places. These places will define the future. They are the stars that remain, burning slowly, carefully releasing the last significant reservoirs of warmth the universe will ever hold. In the next chapter, the focus will narrow to these enduring lights, following their long lives as they illuminate an ever-darkening expanse. For now, Chapter 1 settles into stillness, content in the understanding that beginnings need not be loud, and that even the slowest changes can shape everything that follows. Before leaving this opening era entirely, it is worth lingering a little longer in its quiet breadth. The universe, even at this stage, is not rushing forward. It carries its history gently, allowing the effects of early heat to echo far beyond their origins. Every structure that exists owes its form to the way energy once moved more quickly, more unevenly. The spacing of galaxies, the distribution of stars, the lingering warmth within planets, all are records written in temperature and time. As heat spread, it left behind patterns that endure long after the motion itself has softened. These patterns do not require maintenance. They persist because change has slowed. With fewer strong gradients to disturb them, many structures remain intact simply by continuing as they are. This is one of the quiet gifts of an aging universe. When motion eases, stability becomes easier to sustain. Across immense distances, the same gentle conditions repeat. Regions of space that appear empty are not barren, but calm. They contain particles drifting slowly, radiation passing without urgency, and time unfolding without landmarks. In such places, nothing asks to be noticed. Heat, here, is almost indistinguishable from stillness. It is present, but it no longer insists on change. This near balance is not uniform everywhere, but it is increasingly common. The universe spends more of its volume in this state with each passing era. Brightness becomes localized. Activity becomes rare. Silence, in a physical sense, grows. Yet even this silence is active in its own way. It is the result of countless exchanges, of energy patiently redistributing itself over incomprehensible spans. It is not the absence of history, but the accumulation of it. As this chapter completes its arc, it does so with the understanding that beginnings do not end abruptly. They fade. They merge into what follows. The youthful abundance of heat transitions seamlessly into the long stewardship of stars. Nothing is lost in this passage. Energy remains, time remains. Only the tempo changes. The universe, having learned how to burn brightly, now learns how to glow steadily. With this, Chapter 1 comes fully to rest. Heat has been young. It has shaped everything that exists. And now it prepares to be carried forward more slowly, entrusted to fewer places, across much longer nights. The mind, too, may rest here, settled within a universe that has always known how to move gently from motion toward calm. There is still room to linger, just a little longer, in this opening age, where warmth remains widespread enough to touch many places at once. Even as contrasts soften, the universe carries forward subtle variations that invite quiet observation rather than explanation. Consider the way temperature differences become gentle gradients instead of sharp edges. In earlier times, heat surged across boundaries, driving rapid change. Now, it drifts, it seeps, it passes from one region to another so gradually that the exchange is almost imperceptible. Nothing announces the movement. Nothing marks the moment when one place becomes slightly cooler and another slightly warmer. This slow exchange creates a sense of continuity across space. Regions no longer feel distinct in character. Cold and warmth blend into one another, forming broad zones rather than isolated pockets. The universe becomes less segmented, more unified in its physical state. With this unification comes a deepening quiet. Processes that once relied on strong differences adapt to subtler conditions. Stars adjust their internal balances. Planets settle into long-term thermal states. Even radiation, stretched by expansion, becomes increasingly uniform, smoothing itself across the fabric of space. Uniformity here does not imply sameness in appearance. Galaxies still differ in shape and size. Stars still vary in color and mass. But beneath these visible distinctions lies a growing similarity in energetic conditions. Heat no longer defines identity as sharply as it once did. This shift changes the nature of time itself. When changes occur slowly, moments lose their individuality. There are fewer milestones, fewer thresholds crossed. Time becomes a broad, flowing presence rather than a sequence of events. In such a universe, endurance becomes the dominant trait. Systems that persist do so not by resisting change, but by accommodating it gently. They release energy at rates that can be sustained for immense durations. They accept gradual cooling rather than fighting it. The stars that exemplify this endurance will shape the future far more than the brief, brilliant lights of earlier eras. Their steady glow reflects a universe that has learned moderation. Yet moderation does not mean stagnation. Motion continues, but with restraint. Expansion carries space outward. Particles drift. Radiation glides across widening distances. Everything moves, though nothing hurries. This unhurried motion allows the universe to feel spacious in a new way. Not merely large, but open. There is room for silence. Room for intervals where nothing notable occurs. Such intervals dominate the cosmic experience. Between moments of formation and transformation lie vast stretches where existence is defined simply by persistence. Heat continues to spread. Time continues to pass. As Chapter 1 extends into this deeper calm, it emphasizes that the universe's earliest gift was not brilliance alone, but the conditions for slowness. By allowing energy to disperse, it created the possibility for long-lived structures and extended histories. Without this gradual softening, nothing could endure. Everything would burn out quickly, exhausted by intensity. Instead, the universe chose patience, guided by the quiet mathematics of probability and motion. This patience will define all that follows. Soon, attention will turn fully to the stars that remain luminous against the dark. Their light will become the primary expression of heat's last concentrated forms. Their long lives will trace the universe's transition from active youth into extended evening. For now, this chapter remains suspended in a gentle glow. where warmth is still widespread enough to feel reassuring, and where the future's quiet has not yet fully arrived. Here, at this extended resting place, the universe feels expansive and calm, neither beginning nor ending, simply continuing, allowing heat to move, differences to soften, and time to unfold without demand. And still, there is a final softness to explore, a place where the ideas of this opening age can simply breathe. In this space, nothing new needs to be introduced. The universe is allowed to remain as it is, gently demonstrating the principles already at work. Imagine the slow exchange of warmth across interstellar space, not as a flow with direction, but as a quiet sharing. No region insists on being warmer than another. Differences continue to fade without resistance. Heat does not rush to fill gaps. It merely drifts, equalizing with patience. This patience is not learned, it is inherent. When time is vast, urgency dissolves on its own. Across the cosmos, countless systems follow this same rhythm. They release energy steadily, without excess, without delay. Their histories overlap and interweave, not through dramatic interaction, but through coexistence. Each contributes a small portion of warmth to the whole, then recedes into background. In this way, the universe becomes less a collection of separate events and more a continuous presence. Change is no longer punctuated. It is ambient. The early abundance of heat has not vanished. It has simply been shared so widely that it no longer calls attention to itself. Its influence remains everywhere, quietly shaping conditions, quietly guiding outcomes. This is the state toward which all energetic systems tend when given enough time. It is not an ending, but a resting place along an endless path. Chapter 1 finally settles here, not by concluding, but by lingering. The universe does not close a door on its beginnings. It allows them to fade gently into what follows. With warmth dispersed and motion softened, the stage is ready for the next long movement, the age in which stars carry the remaining contrasts forward, illuminating an ever-widening night. Until then, the cosmos remains calm, expansive, and unhurried, holding space for rest in the same way it has always held space for change. Chapter 2 The Long Evening of the Stars. Somewhere in the vastness of space, a star shines steadily, as it has for a very long time. It does not blaze in a way that demands attention. It simply glows, releasing warmth into the darkness, one moment after another, with a patience that feels older than any story we can tell. In Chapter 1, we rested in the universe's beginnings, where heat was young and abundant, where contrasts were strong enough to shape matter into structure. Now the focus narrows. The universe has stretched outward. Space has grown larger. The average temperature has fallen, and the remaining islands of warmth have become more important, not because they are rare, but because they are the last places where heat is still concentrated enough to drive large change. These islands are the stars. A star is a long conversation between gravity and heat. Gravity gathers matter inward. Heat, generated in the core, pushes outward. When these forces balance, the star becomes steady, holding itself in place without effort, shining not because it chooses to, but because equilibrium requires a constant release. That release is the star's light. Every second, an ordinary star converts an enormous amount of mass into energy through nuclear fusion. In the core, hydrogen nuclei merge to form helium. The process releases photons and heat, which slowly work their way outward. By the time that energy reaches the star's surface, it has been shared and moderated through countless interactions. It finally escapes as light, spreading into space, carrying the star's warmth away. This outward flow is what keeps the star stable. It is also what slowly empties the star of its usable fuel. In human terms, a star seems eternal, but in cosmic terms, it is simply long-lived. Its brightness is not permanent. It is an extended farewell. The universe's long evening begins when star formation slows. In the earlier chapters of cosmic history, galaxies were rich in cold gas. That gas could collapse into new stars again and again, replenishing the sky with fresh light. But over time, much of that gas is locked away in existing stars, blown outward by stellar winds, or heated until it can no longer collapse easily. The raw material for new stars becomes harder to gather. Star birth continues, but more cautiously. In many galaxies, including our own, most of the brightest, shortest-lived stars are already gone within a relatively small cosmic span. Massive stars burn hot and fast. They shine with intensity, but their lives are brief. They exhaust their fuel quickly, and when they die, they leave behind remnants, dense cores, expanding clouds of enriched gas, and in some cases, black holes. These massive stars are like bright sparks at the beginning of the evening. They matter because they shape their surroundings. They forge heavy elements. They stir galaxies with radiation and winds. But because they live so briefly, they are not the true rulers of the long future. The long evening belongs to the small stars. Red dwarfs, the most common type of star in the universe, burn their fuel slowly. They are small, cool, and dim compared to stars like the Sun. Yet their modest nature is what grants them endurance. They conserve their hydrogen with remarkable efficiency, shining quietly for trillions of years. A trillion years is a number that can feel like a blank space in the mind. It is not something we can picture in detail. But in the long evening of the universe, it is a natural unit of time. It is the time scale over which the smallest stars continue to glow. As other stars fade, these red dwarfs remain. Galaxies gradually become older places. Their populations shift from brilliant, short-lived stars to steady, faint ones. The average light becomes softer and redder. The bright blue glare of youth gives way to gentler hues. Even this shift is not sudden. It takes billions of years. It unfolds so gradually that no one moment marks the change. Yet the direction is clear. With fewer new stars forming, the universe's supply of concentrated heat slowly declines. Not because energy disappears, but because the places where it can be gathered into intense, useful gradients become fewer. In the distant future, night skies will still hold stars, but they will be scattered differently. Many galaxies will have drifted beyond one another's horizons due to expansion. From within a single galaxy, the visible universe will shrink, not in size, but in what can be seen. This is a quiet kind of isolation. The light that remains will come from what is nearby. The local stars, the local remnants, the slow glow of long-lived dwarfs. And as this evening deepens, even these enduring lights will change. A red dwarf does not burn forever. It simply burns longer than almost anything else we know. Over immense spans of time, it too converts hydrogen to helium. Its internal balance adjusts slowly. Its brightness changes gradually. It warms slightly, then dims, moving through a life cycle so slow that it almost feels like stillness. The star's heat continues to leak outward, photon by photon, dispersing into the cold. With each release, the universe grows more even in temperature, more willing to rest. In this long evening, the universe is still active, but its activity is increasingly gentle. The bright fireworks of youth have faded. The steady lanterns of small stars remain. and in their slow, patient glow, we can sense the universe beginning to settle into a deeper quiet, one that will last far longer than any age of brilliance. For now, we stay with the stars. We listen to their steady release. We follow their light as it travels outward, becoming thinner, softer, and more widely shared. Because in the long evening of the universe, the stars are not just lights in the sky. They are the last great keepers of heat. As the long evening unfolds, the pace of the universe becomes defined by endurance rather than intensity. Stars no longer compete for attention through brilliance. Instead, they persist through steadiness, offering light that is modest but reliable, warmth that is gentle but long-lasting. This shift changes the character of galaxies. Where once they shimmered with clusters of bright, short-lived stars, they now glow more softly. Their light becomes diffuse, spread across wide regions, with fewer sharp points of brilliance. The night sky, viewed from within such a galaxy, would feel calmer, less crowded, and more spacious. In this era, time stretches comfortably. Millions of years pass without notable change. Orbits repeat with quiet regularity. Stellar populations age together, their differences slowly diminishing. Even stellar death, once dramatic, becomes subdued. For stars similar to the Sun, the end arrives gradually. As hydrogen fuel in the core is consumed, fusion slows. The balance between gravity and heat shifts. The star expands into a red giant, shedding its outer layers into space. These layers drift outward, glowing faintly before dispersing, enriching the surrounding medium with heavier elements. What remains is a white dwarf, a dense, Earth-sized remnant, no longer producing energy through fusion. It shines only with leftover heat, radiating it slowly into the surrounding darkness. This cooling is unhurried. A white dwarf can glow faintly for trillions of years, its temperature declining so gradually that the change is almost imperceptible. Over unimaginable spans of time, it cools toward equilibrium, becoming darker, quieter, and more still. In a universe that values patience, even remnants endure. Elsewhere, more massive stars meet different ends. Their deaths scatter energy and matter widely, but even these moments contribute to the same trend. The heat released spreads outward, thinning as it goes. Nothing remains concentrated for long. Neutron stars spin and cool. Black holes form and wait. Each object becomes a long-term participant in the universe's slow redistribution of energy. As the long evening deepens, galaxies themselves begin to drift beyond one another's reach. Expansion stretches space so thoroughly that distant systems fade from view, their light redshifted beyond detection. From any single location, the universe appears smaller, quieter, more intimate. This isolation is not abrupt. It unfolds over immense spans of time, with no clear boundary between connection and separation. One by one, distant galaxies slip beyond the cosmic horizon, leaving only the local group visible. In this quieter cosmos, the remaining stars take on greater significance. Their light defines the limits of perception. Their warmth shapes the last active environments. Red dwarfs continue their steady glow, outlasting all others. They burn hydrogen so efficiently that their lifetimes extend far beyond the present age of the universe. For trillions of years, they provide modest illumination, sustaining faint planetary systems and lingering warmth. Yet even this endurance has limits. Over time, red dwarfs gradually exhaust their fuel. Their fusion slows. Their brightness changes subtly. Eventually, they too cease producing new energy, leaving behind cooling remnants that fade into darkness. The long evening does not end with a single sunset. It dims gradually, star by star, over spans so long that beginnings and endings blur together. Throughout this era, heat continues its quiet journey outward. Each photon released by a star travels into expanding space, its energy stretched thinner, its influence softened. The universe grows more even, more balanced, more still. And yet, it is not empty. Energy remains present everywhere, shared across vast distances. Motion persists, though subdued. Time continues, unmarked by events but rich in duration. As Chapter 2 expands, it invites us to remain with this steady fading, to listen to the universe as it learns how to glow less brightly, but for much longer than before. This is not loss. It is completion of a cycle. The stars, once born from youthful abundance, now carry the universe gently toward rest, releasing their warmth patiently, until even the longest evenings give way to deeper quiet. As the universe continues through this long evening, its light becomes something that must be waited for. Photons travel immense distances before they are noticed, and many pass unseen, their journeys uninterrupted for ages. Space itself has grown generous with room, allowing energy to wander without urgency. In this era, galaxies are quieter places, their internal motions slow, as interactions become rare. Stellar neighborhoods spread out, leaving more darkness between points of light. Where once star clusters formed in abundance, now only occasional gatherings occur, each one a gentle echo of earlier times. Within these galaxies, the remaining stars feel settled. Their rhythms are steady, their changes subtle. They no longer transform their surroundings dramatically. Instead, they maintain what already exists, releasing heat just quickly enough to prevent collapse, just slowly enough to last. The light they emit is softer now, richer in longer wavelengths. Blue brilliance has faded. Reds and deep ambers dominate, bathing space in subdued tones that carry warmth without intensity. This light does not command attention. It invites quiet observation. Planets orbiting such stars experience long, unchanging eras. Their skies would glow dimly, their days and nights passing without sharp contrast. If warmth exists on their surfaces, it does so gently, sustained by steady stellar output rather than bursts of energy. Time stretches comfortably here. Thousands of generations could pass beneath an unchanged sky. Seasons would shift slowly, if at all. The universe offers no rush. As stars continue their patient work, the matter they once gathered begins to drift apart again. Stellar winds and gentle ejections spread atoms into surrounding space. These atoms carry heat briefly, then release it, joining the shared background that fills the cosmos. Nothing is reclaimed, nothing is wasted. Each contribution simply becomes part of a growing, evenly distributed whole. White dwarfs persist in this quiet environment, glowing faintly as they cool. Their light is not born of fusion, but of stored heat, slowly escaping after billions of years of containment. They are reminders of earlier brilliance, still present, still participating in the universe's gradual settling. Over unimaginable spans, these remnants grow darker. Their temperatures fall. Their emissions weaken. Eventually, they approach the surrounding cold so closely that they are nearly indistinguishable from it. This approach toward balance is unforced. It happens because there is nowhere else for heat to go but outward. Neutron stars, dense and compact, follow a similar path. Their internal energies dissipate through radiation and subtle interactions. Their rotations slow. Their magnetic activity weakens. Over time, even these extreme objects become quiet. Throughout the long evening, black holes remain. They do not shine in the conventional sense. They hold matter and energy tightly, contributing little warmth to their surroundings. Yet even they are not exempt from the universe's gentle accounting. Over spans so vast they defy easy description, they too release energy, thinning themselves gradually. The long evening is therefore not static. It is dynamic in the slowest possible way. Change continues, but it unfolds on timescales that smooth away any sense of urgency. As the number of active stars declines, the universe's remaining warmth becomes increasingly diffuse. Each source releases energy into a larger, emptier volume. The background temperature rises slightly in some places, but never enough to spark new complexity. The cosmos becomes dominated by memory rather than creation. What exists is largely what has already formed. New beginnings are rare, and when they occur, they are modest. Yet there is comfort in this stability. Without rapid change, systems persist, structures endure. Time becomes something that can be inhabited rather than measured. As Chapter 2 continues, it rests within this steady dimming. The stars still shine, but they do so without hurry, without spectacle, offering their remaining heat as a slow, continuous gift to an ever-expanding dark. This is the universe learning how to let go of light, not abruptly, not reluctantly, but with the same patience that guided it from the beginning. As the evening deepens further, the universe begins to feel spacious in a new way, not simply large but open. With fewer stars forming and fewer bright events unfolding, vast regions experience little change for immense spans of time. Darkness becomes familiar, not as an absence, but as a stable presence. In these stretches, the remaining light feels deliberate. Each star that shines does so with quiet purpose, releasing its warmth steadily, without excess. The sky is no longer crowded with brilliance. Instead, it is punctuated by isolated glows, separated by wide intervals of darkness that invite stillness. These intervals shape perception. When change is rare, awareness settles. Time is no longer marked by frequent transitions, but by continuity. The universe moves forward, but it does so without announcing itself. Within aging galaxies, stellar orbits become almost meditative in their regularity. Stars trace the same paths again and again, their motions slow and predictable. Gravitational interactions still occur, but they are gentle, rarely disrupting the overall calm. The material once expelled by dying stars, gas, dust, heavier elements, drifts through space with little urgency. Without abundant cold clouds to gather it, this matter spreads thinly, contributing more to background presence than to new creation. This spreading reinforces the evening's quiet. With each dispersal, the chances of collapse diminish. Heat and matter become increasingly unwilling to gather tightly again. Red dwarfs continue their long vigil. For trillions of years, they remain almost unchanged, their steady glow a reminder of earlier abundance. Around them, planets orbit through ages that feel timeless. Surface conditions, if present, alter only slowly, shaped by faint stellar output and internal warmth that leaks outward at an unhurried pace. In such environments, extremes are rare. Temperatures vary little. Radiation arrives gently. If motion exists, it does so without urgency. The universe has entered an era where moderation is the dominant trait. White dwarfs, scattered throughout galaxies, slowly approach thermal balance with their surroundings. Their stored heat dissipates through faint radiation, thinning year by year, millennium by millennium. They do not extinguish suddenly. They simply grow quieter, blending more fully into the cosmic background. Neutron stars follow a similar path. Once among the most extreme objects, They now spend eons releasing residual energy, their remarkable densities and fields gradually losing influence. What remains is persistence rather than power. Even black holes, often imagined as eternal, participate in this long accounting. Over unimaginable durations, they release energy so slowly that the process feels almost theoretical. Yet it proceeds all the same, guided by the same tendency toward balance that shapes everything else. As these processes unfold, the universe's temperature differences continue to soften. Warmth still exists, but it is increasingly shared. The background becomes richer in distributed energy, even as individual sources fade. This sharing does not spark new activity. It simply raises the floor, smoothing contrasts further. By this stage of the long evening, the cosmos feels settled, not finished, but calm. Its remaining motions are gentle enough to go unnoticed without careful attention. Chapter 2 lingers here, allowing the stars to shine as they are now, fewer, steadier, and quieter, while the universe learns how to sustain itself with minimal change. The night grows longer, the lights remain, and heat, once wild and abundant, now moves with a softness that feels almost like rest. As the universe settles more deeply into this extended evening, the scale of time stretches beyond familiar boundaries. Thousands of years pass without noticeable change. Millions drift by with only the subtlest adjustments. Even billions of years feel like gentle breaths rather than milestones. In this softened tempo, the remaining stars become anchors of continuity. Their steady light offers reference points in a cosmos where events are rare. Each one marks a place where heat still gathers briefly before joining the wider calm. Around these stars, space itself feels less crowded. The distances between objects grow more pronounced as expansion continues. Light takes longer to cross the gaps, and in many cases, it never reaches another star or planet at all. Instead, it travels onward, gradually red-shifting, its energy thinning until it blends into the faint background. This thinning of light does not diminish its meaning. It simply changes its role. Rather than driving dramatic processes, it contributes quietly to the universe's shared reservoir of energy. Galaxies, once sites of frequent interaction, now experience long periods of isolation. Their internal structures remain largely intact, but their connections to the wider cosmos loosen. From within such a galaxy, the night sky appears increasingly empty, with fewer distant lights to mark the passage of time. This emptiness is not abrupt. It arrives slowly, almost politely, giving the universe ample time to adjust. Within these galaxies, the stellar population continues to age. Bright remnants from earlier eras grow scarce. The sky becomes dominated by faint, long-lived stars and cooling remnants. The overall glow dims, though never entirely disappears. In this environment, change becomes a matter of patience. White dwarfs cool steadily, releasing their stored heat over spans so long that they appear almost static. Neutron stars lose their rotational energy and magnetic strength, their once dramatic signals fading into quiet regularity. Even the most energetic objects adapt to the evening's pace. As energy spreads ever more evenly, the contrast between sources and surroundings lessens. Temperature differences soften to the point where new processes struggle to begin. The universe does not forbid change. It simply makes it less likely. This gradual narrowing of possibility is one of the defining features of the long evening. The range of outcomes contracts, not through force, but through probability. There are simply fewer ways for energy to concentrate again. Yet within this narrowing, stability thrives. Systems that exist tend to remain. Orbits endure. Structures persist. The cosmos becomes a place where what is already present continues, gently and reliably. The stars that remain active serve as quiet stewards of this phase. They release their warmth at rates that sustain equilibrium without excess. Their light marks time not by brilliance, but by duration. Over trillions of years, even these stewards approach the ends of their luminous lives. Their fusion slows. Their balances shift. Their contributions to the universe's heat become ever smaller. Still, they do not vanish suddenly. They fade with remarkable patience, allowing the universe to adapt smoothly to each loss. As Chapter 2 continues, it rests within this deepening calm. Where stars are fewer, light is softer, and time stretches wide enough to hold silence comfortably. The evening has not yet given way to night, but the path is clear. The universe is learning how to exist with less light, less contrast, and less motion, preparing gently for an even quieter chapter ahead. As the long evening stretches onward, the presence of stars begins to feel less like a given and more like a quiet privilege. Each remaining point of light stands alone, separated from others by distances that grow steadily larger. The sky becomes a place of long pauses, where darkness is the rule and illumination the exception. In this thinning light, the universe adopts a new rhythm. Instead of cycles of creation and destruction, there are extended periods of simple continuation. Stars shine, remnants cool, space expands. Nothing interrupts this flow. The red dwarfs that remain active now define the pace of the cosmos. Their lifetimes are so long that they blur the boundary between change and permanence. A single star may shine through eras that would encompass the entire visible history of the universe many times over. Its brightness alters so slowly that no observer could mark the moment. Around such stars, planetary systems persist quietly. Orbits remain stable. Temperatures vary little. If internal heat remains within these worlds, it leaks outward gradually, sustaining slow geological motion before easing into stillness. These environments are not dramatic. They are enduring. As trillions of years pass, the balance within red dwarfs shifts. Helium accumulates. Fusion grows less efficient. Their light dims incrementally, their warmth reduced in steps so small they feel continuous. Eventually, even these long-lived stars approach the ends of their luminous phases. What they leave behind are cooling remnants, dense, quiet objects that no longer generate energy, but release what remains over immense spans. Their presence adds to the background without altering it. By this stage of the evening, the universe holds very few active sources of concentrated heat. Most energy is already widely shared, spread thin across expanding space. Temperature differences are subtle, rarely sufficient to power new activity. The EBU cosmos does not resist this state. It accepts it. With fewer stars to mark time, the passage of eras becomes abstract. Without frequent events, time feels less like a sequence and more like a condition, something that exists without drawing attention to itself. Expansion continues steadily, carrying galaxies farther apart until even local groups begin to feel loosely bound. The visible universe contracts in experience, though it grows larger in reality. Light, when it appears, travels through vast emptiness, unimpeded, unobserved. Its energy stretches, softens, and eventually blends into the faint thermal background that fills all space. In this quiet, the distinction between foreground and background dissolves. Objects no longer stand out sharply against their surroundings. Everything becomes part of a shared, gently moving whole. Chapter 2 lingers here, near the far end of the stellar era, where light still exists but no longer dominates. The universe has learned how to live with very little contrast, how to sustain itself with minimal change. The long evening is almost complete. Ahead lies a state even quieter, where stars are gone and remnants have cooled nearly to equilibrium. The story will continue there, not with events, but with stillness itself. For now, the final stars continue their patient glow, offering the last steady warmth before the universe drifts into deeper rest. As the stellar era nears its quiet conclusion, the remaining lights feel almost ceremonial in their persistence. Each one shines not because the universe requires it, but because it has not yet finished releasing what it holds. The glow continues, gentle and unforced, as if honoring the long agreement between heat and gravity one final time. These last active stars are few, widely spaced, and deeply patient. Their light travels through expanses so large that it rarely encounters anything before thinning into the background. When it does meet matter, the exchange is subtle, a brief, warming, a soft interaction, before the energy moves on again, further diluted by distance and time. Around these final stars, the surrounding darkness is vast and familiar. There is no sense of encroaching loss. Darkness has become the default state, the calm in which light briefly appears and then fades. The red dwarfs that remain luminous now approach the end of their long endurance. Fusion slows until it nearly stops. Their internal balances shift gently, without sudden collapse or flare. What remains is a gradual dimming, a soft withdrawal of warmth rather than a dramatic end. As each star reaches this stage, the universe adjusts seamlessly. There is no gap to fill, no replacement required. The shared background of energy absorbs the contribution without change in character. White dwarfs, the remnants of earlier stars, continue their slow cooling, their faint glow becoming ever harder to distinguish from surrounding space. Over immense durations, they approach thermal equilibrium, joining the quiet majority of objects that no longer stand out. Neutron stars, once marked by extreme density and motion, now spin so slowly and emit so little energy that they pass unnoticed among the star's remnants. Even their most distinctive traits soften with time. Black holes persist as silent participants. Their presence is felt not through light, but through the absence of it. Yet even they are part of the same gradual accounting, releasing energy so slowly that the process blends into the universe's overall stillness. With each passing era, the number of places where heat remains concentrated enough to drive change diminishes. The universe becomes increasingly uniform in temperature, increasingly unwilling to support motion beyond the faintest drift. Time here loses its sense of direction. Without events to mark progression, moments blend together. Duration becomes the dominant experience. The universe simply continues. Chapter 2 comes to rest in this extended twilight, where stars are nearly gone and their remnants quietly fade. The long evening has fulfilled its role, allowing heat to disperse with patience and grace. What follows is not an ending, but a deeper quiet, a state where balance is nearly complete, where energy remains but change has little reason to occur. The next chapter will move into that stillness, where the universe rests not because it must, but because it has nowhere else to go. For now, the last stars finish their gentle glow, and the cosmos waits, calm and unhurried, ready for rest. There is still a little room to linger at the edge of this evening, where the presence of stars has become rare enough to feel intentional. In this space, Nothing urges the universe onward. The remaining light simply continues until it does not, without ceremony or resistance. In the long intervals between stellar endings, the cosmos feels almost unchanged. Darkness holds steady. Expansion proceeds quietly. The background, temperature remains nearly uniform, rising or falling only by the faintest amounts over spans that defy counting. Here, patience is complete. The universe no longer anticipates new brightness. It accepts each remaining glow as a passing moment rather than a promise of continuation. When the last red dwarfs finally cease producing new light, there is no sudden transition. The sky does not noticeably dim because it has already grown accustomed to darkness. The final change blends seamlessly into what was already present. Heat continues to exist everywhere, shared so widely that it can no longer gather itself into stars or motion. Energy remains real, but inactive, like a calm surface without ripples. With this, the stellar evening dissolves fully into night, not as an event, but as a condition. The universe rests in a state where light has finished its long work, and warmth has found its way outward. Chapter 2 settles here, allowing the stars to release their final traces of influence and fade into the same quiet background that has been growing all along. Nothing is lost. Nothing collapses. The universe simply becomes very still. From this stillness, the final chapter will unfold, not with stories of objects and motion, but with the gentle physics of near balance, where change is possible only in the smallest, slowest ways. In this final stretch of the stellar evening, the universe feels almost self-contained, as though it has folded inward, not in space, but in activity. With nearly all sources of light gone quiet, what remains is a broad, even calm that stretches without interruption. The background glow that fills space is now the dominant presence. It is faint, uniform, and steady, carrying the accumulated warmth of countless stars that once shone across billions and trillions of years. This glow does not illuminate objects or cast shadows. It simply exists, a shared remnant of earlier motion. Without bright stars to define direction or distance, space loses some of its visual structure. There are fewer reference points, fewer markers to suggest scale. The universe becomes harder to measure, not because it has changed size, but because nothing stands out sharply enough to anchor perception. Time behaves similarly. With events so rare and changes so subtle, moments blend together. Duration replaces sequence. The universe does not progress from one state to another, so much as it remains within a slowly evolving condition. Even expansion, which continues without pause, becomes difficult to notice. Space stretches, but with so little activity to trace that stretching, the motion feels abstract. Galaxies that once drifted apart visibly are now too distant, too dim to register. The remnants that persist, cooling white dwarfs, silent neutron stars, isolated black holes, occupy this space without interacting. Their presence adds weight to the universe, but little motion. They are landmarks only in theory, not in experience. Heat, now thoroughly shared, no longer prefers one place over another. Temperature differences exist only in the smallest degrees, insufficient to drive large-scale change. Energy remains present, but it has reached a state where it cannot easily be directed. This is the completion of the stellar era's work. The stars have not failed. They have finished. Chapter 2 comes fully to rest here, in a universe that has released nearly all of its concentrated warmth into a vast, even background. Light has done its long task of spreading energy outward, and in doing so, it has made itself unnecessary. What lies ahead is not darker in any meaningful sense, but quieter still, a continuation of this calm toward near-perfect balance. With this final softening, the long evening of the stars fades completely, leaving the cosmos prepared for a chapter defined not by light or motion, but by rest itself. Chapter 3. A universe at rest. After the long evening of the stars has faded, the universe does not arrive at an ending. It arrives at a condition. Light has finished its work of carrying heat outward. Motion has softened almost everywhere. What remains is not emptiness, but a vast, quiet balance. In this era, the universe is filled with energy that has nowhere particular to go. Heat is still present in every direction, shared so evenly across space that it no longer forms strong currents or gradients. Without differences to drive motion, change becomes rare, subtle, and unhurried. The background temperature of the cosmos is nearly uniform. It drifts slowly downward as space continues to expand, but the change is so gradual that it feels timeless. There are no warm regions set sharply against cold ones, no bright sources releasing concentrated light. Everything exists at nearly the same level of quiet warmth. Time here feels different. Without events to mark it, time becomes something experienced as duration rather than sequence. Moments blend together. Eras overlap. The universe continues, but it does not announce itself with transitions. The remnants of stars still exist. White dwarfs have cooled until their temperatures are almost indistinguishable from the surrounding space. Neutron stars are silent and inert. Black holes remain as faint distortions in space-time, isolated and widely separated. These objects do not interact much. The distances between them are enormous, and gravity works too slowly, too gently, to bring them together again in meaningful ways. The universe has grown too spacious for frequent encounters. Heat, once gathered and released by stars, now drifts without preference. It moves only when chance allows, spreading ever more evenly as expansion continues. Energy is conserved, but usefulness has faded. This is the state sometimes called thermal equilibrium. It does not mean that nothing exists. It means that everything exists at nearly the same level of energy, with no easy way to create motion or structure. In such a universe, processes that once seemed fundamental become unlikely. Chemical reactions slow until they are almost non-existent. Orbits persist, but without change. Radiation passes through space without leaving a trace. Yet the universe is not frozen. Particles still move, though minimally. Space still stretches. Time still passes. Change has not ended. It has become exceedingly gentle. Over incomprehensible spans, even the faint distinctions that remain continue to soften. Temperature differences diminish further. Energy spreads across larger volumes. The universe drifts closer to perfect balance, though it never quite arrives. There is no final moment when this balance is reached. The approach itself is what defines the era. In this near rest, the cosmos holds the memory of everything that came before. Every star that shone, every galaxy that formed, every exchange of heat contributed to this calm. The stillness is not an absence of history, but its quiet accumulation. As Chapter 3 unfolds, it will linger in this state, exploring what it means for a universe to continue without urgency, without direction, and without need for change. Here, at the edge of motion, the universe rests, not because it must, but because it can. In this resting state, the universe no longer emphasizes difference. Where once temperature, density, and motion varied widely from place to place, those variations have softened into near sameness. Space feels evenly weighted, evenly tempered, evenly quiet. Nothing stands out sharply enough to demand attention. The faint background warmth that fills the cosmos is the legacy of everything that came before. It is the accumulated result of countless stars releasing their energy, of light traveling and stretching, of matter exchanging heat over unimaginable spans. This warmth is not strong enough to shape new structures, but it is present everywhere, a shared inheritance. Because the background is so uniform, heat rarely flows in noticeable ways. There are no strong currents, no preferred directions. Energy drifts only through the smallest random motions, guided by chance rather than purpose. In such a universe, the familiar drivers of change fall quiet. Without gradients, there is little to push matter into new arrangements. Without pressure differences, motion has no reason to accelerate. Without concentrated sources of energy, complexity finds no foothold. And yet, existence continues. Particles still possess motion, though it is slight. They vibrate gently, carrying the minimal energy allowed by the conditions of space. Radiation still moves, passing through vast emptiness without interaction. Gravity still curves space-time, though its influence unfolds over timescales so long that its effects are nearly imperceptible. The universe has not stopped. It has simply slowed to a pace where change blends seamlessly into continuity. In this era, isolation becomes nearly absolute. The distances between objects are so great that encounters are extraordinarily rare. A particle may drift for eons without nearing another. A remnant star may circle a galaxy's center without ever passing close to a neighbor. These long separations further reinforce stillness. With little interaction, systems persist in their current states. What exists tends to remain as it is. Black holes, once among the most dramatic objects in the cosmos, now sit quietly within this vast calm. They are isolated, widely spaced, and surrounded by near-uniform space. Over extreme spans of time, they continue their slow release of energy, but the effect is subtle, blending into the background rather than disrupting it. The universe's expansion continues as well. Space stretches gently, increasing distances and further diluting energy. The background temperature declines by fractions so small that they resist description. Each moment differs from the last only in theory, not in experience. Time itself feels less directional here. Without events, to punctuate it, there is no strong sense of before and after. Duration dominates perception. The universe simply is, moment after moment, without transition. As Chapter 3 deepens, it dwells within this calm, not to search for an ending, but to observe what persistence looks like when nearly all change has softened away. The cosmos has reached a state where nothing urges it onward, and nothing pulls it back. It continues because continuation requires no effort. Here, in this broad equilibrium, the universe rests, carrying energy without motion, history without events, and time without milestones. As the universe settles more deeply into this near balance, its vastness becomes less about distance and more about sameness. Where once regions could be distinguished by brightness or motion, now they differ only in the smallest details. The cosmos feels continuous, without edges or focal points, stretching evenly in every direction. In this state, energy is no longer something that travels with intention. It drifts, shared among particles so uniformly that no pathway stands out. Heat exists, but it does not seek colder places. Cold exists, but it does not invite warmth. The gentle movements that remain are random, without preference, without destination. The familiar idea of cause and effect softens here. When changes are so small and so slow, they blend into one another. An interaction may occur, but its consequences are minimal, easily absorbed by the surrounding calm. Nothing cascades, nothing amplifies. This does not mean that the universe is inactive. It means that activity has become indistinguishable from stillness. Space continues to expand, but with no structures left to trace that expansion clearly. The motion feels abstract. Distances grow, yet nothing appears to move. The background temperature continues its gradual decline, but the difference between moments is too small to feel. Even the passage of time becomes gentle. Without landmarks, there is no sense of progress toward anything. The universe does not anticipate a future state. It simply continues, resting within the conditions it has created. Particles vibrate faintly, maintaining the minimal motion allowed by their energy. Radiation glides through space, rarely interacting. Gravity shapes space-time subtly, but with so little matter nearby, its influence unfolds without drama. Over stretches that exceed comprehension, these quiet processes persist. They do not build toward an outcome, they simply endure. In this endurance, the universe reveals a different kind of permanence. Not the permanence of unchanging form, but the permanence of balance. Conditions remain stable, not because they are fixed, but because there is nothing left to disturb them. What once felt like an ending now feels like a continuation of rest. The universe has not stopped. It has arrived at a pace so slow that change and constancy are nearly the same. Chapter 3 remains here, allowing the mind to settle into this wide calm where energy is evenly shared, motion is minimal, and time stretches without demand. There is no final moment waiting beyond this state. There is only the ongoing presence of a universe content to exist quietly, carrying its history forward without movement, without urgency, and without need. In this quiet equilibrium, the universe becomes gentle to observe. There is nothing that asks to be followed, nothing that insists on explanation. Conditions persist without tension. The fabric of space holds its shape not through rigidity, but through the absence of strain. Where motion remains, it is subtle enough to feel like breathing. A slow expansion, a faint vibration, a gradual sharing of energy that has already been shared countless times before. These movements do not accumulate. They do not build toward anything. They simply occur, evenly and without emphasis. The notion of scale loses clarity here. Without landmarks, distances feel interchangeable. Near and far carry little meaning when everything exists at nearly the same energetic level. Space becomes less a collection of places and more a continuous presence. In such a universe, memory is carried differently. It is not preserved in structures or events, but in conditions. The even background warmth holds the imprint of stars long gone. The smoothness of space reflects countless interactions now resolved. History remains, but it no longer calls attention to itself. Time, too, becomes something that can be inhabited rather than tracked. Without beginnings or endings to mark it, time feels wide and accommodating. Moments do not press forward. They rest alongside one another, indistinguishable in character. The universe continues expanding, but the expansion feels less like movement and more like allowance. Space makes room for what already exists, even as nothing new arrives to fill it. Energy thins gently, without urgency, across volumes too large to visualize. Over stretches that exceed imagination, the remaining distinctions soften further. Tiny temperature differences fade. Minor motions diminish. The approach toward balance continues, though it never completes. There is always a little change left to release, a little motion left to ease. This unending approach is itself a form of rest. Without a final state to reach, the universe remains suspended in calm, free from expectation. Chapter 3 lingers here, allowing this calm to unfold without direction. There is no next step to anticipate, no transition to prepare for. The cosmos exists as a steady presence, energy shared, motion minimal, time unhurried. Here, the universe does not conclude. It simply remains. In this sustained calm, attention no longer needs to move. There is nothing ahead that requires preparation, nothing behind that asks to be remembered. The universe holds itself gently, without pressure to change or remain the same. It simply exists within the conditions it has reached. The evenness of energy brings a kind of quiet clarity. Without sharp contrasts, there is no pull in any direction. Heat does not gather. Cold does not deepen. Everything rests close to the same gentle state, differing only by the smallest margins, differences too slight to guide motion. Space, in this era, feels soft rather than vast. Its openness is not defined by distance but by ease. Nothing resists expansion, and nothing depends on closeness. The fabric of the cosmos stretches without tension, accommodating what remains with patience. Particles continue their faint motion, but the movement is so slight that it feels more like presence than activity. Radiation glides through space without interruption. Gravity curves space-time quietly, its influence spread thin across immense regions. These processes do not compete. They do not hurry. They coexist. As distinctions fade further, the universe becomes increasingly self-similar. One region resembles another. Conditions repeat gently across enormous scales. The cosmos feels continuous, uninterrupted by borders or features that demand attention. In such a setting, the idea of direction dissolves. There is no forward or backward in any meaningful sense. Expansion continues, but without landmarks. It does not feel like motion. Cooling continues, but without contrast, it does not feel like change. What remains is duration, broad, open, and unforced. The universe has no expectation of what comes next. It does not anticipate an end or a renewal. It rests within the simple fact of continued existence, supported by the quiet rules that have always guided it. Here, persistence requires no effort. Balance maintains itself because there is nothing left to disrupt it. Chapter 3 stays with this gentle equilibrium, allowing the mind to settle into the same openness. There is no need to follow a narrative, no need to hold onto detail. The universe offers only presence, wide and calm. And in that presence, everything is already at rest. As this calm persists, the universe becomes a place where nothing competes for attention. There are no peaks or valleys of activity, no moments that rise above the rest. Everything unfolds at the same gentle level, evenly distributed across space and time. In such an environment, the idea of urgency has no meaning. Without gradients to resolve or structures to build, there is nothing to hurry toward. The universe does not wait for an outcome. It rests within a steady present that extends indefinitely in all directions. Heat, now fully shared, exists as a quiet background rather than a force. It does not travel in streams or waves. It does not collect. It simply remains, carried by particles and radiation that drift without preference. This shared warmth is enough to sustain minimal motion, but not enough to inspire change. Particles vibrate faintly, maintaining the smallest expression of energy allowed by their surroundings. Radiation passes through space without interaction, leaving no imprint behind. Space itself feels settled. Expansion continues, but without resistance or strain. The stretching of distances does not alter relationships, because there are so few relationships left to alter. Everything that exists is already far apart, already independent. In this era, gravity has little work to do. With matter so widely dispersed, its influence unfolds slowly, gently, rarely bringing objects together. Orbits persist where they exist, but they do so without variation, tracing the same paths endlessly. The universe has reached a state where repetition replaces progression. Patterns remain, but they no longer evolve. They continue simply because nothing interrupts them. Time passes without markers. There are no events to separate one moment from the next. Duration stretches smoothly, without breaks or transitions. The cosmos experiences itself as an ongoing presence rather than a sequence of changes. In this presence, history feels distant but complete. Everything that could happen has already contributed to the conditions that now prevail. The universe carries that history quietly, without replay or reminder. Chapter 3 continues to rest here, allowing the idea of stillness to deepen. There is no need to move forward, because forward has lost its meaning. The universe remains, energy evenly shared, motion minimal, time unpressured, existing gently, without direction, without demand. In this final settling, the universe no longer presents itself as a story to be followed. It becomes a condition to be inhabited. There is nothing unfolding ahead, nothing resolving behind. The present stretches wide enough to hold everything that remains. Without contrast to draw attention, awareness drifts naturally. The eye has nothing to fix upon. The mind has nothing it must hold. Space offers no signals, only openness. Time offers no milestones, only continuity. Heat, now so evenly shared that it barely registers as warmth, rests quietly within matter and radiation alike. It neither rises nor falls in any noticeable way. It simply persists, a gentle baseline that supports the faint motion still allowed by the universe. Particles continue their minimal vibrations, not striving, not colliding with purpose. Radiation passes through space without interruption, its journey endless and uneventful. Gravity curves space-time softly, but with so little nearby matter, its influence remains diffuse and patient. Nothing here asks to be explained. The universe has reached a state where effort is unnecessary. Balance maintains itself because there is no longer anything to upset it. The rules that once guided dramatic change now sustain quiet persistence. As expansion continues, it does so without consequence. Distances grow, but nothing depends on closeness. Energy thins further, but nothing requires it to be concentrated. Cooling proceeds, but without contrast, it has no character. This is not a final destination. It is simply how things are, when time is long enough and motion has had room to soften completely. Chapter 3 remains within this calm, allowing stillness to extend without boundary. There is no moment when the universe stops. There is no moment when it arrives. It continues, gently and indefinitely. Here, at the close of this journey through heat and time, nothing needs to happen next. The universe rests. Even within this resting state, the universe retains a gentle sense of continuity. Not a progression, not a movement toward anything new, but a soft persistence that carries on without effort. Existence no longer depends on exchange or transformation. It sustains itself simply by remaining. The quiet here is not fragile. It does not need to be protected. With no forces pulling strongly in opposing directions, there is nothing to disturb the calm. The universe has reached a condition where stillness is stable, where balance does not require correction. Heat so evenly distributed that it has lost all preference, rests within every particle and every wave. It does not announce itself as warmth or cold. It exists as a shared baseline, supporting the faintest possible motion without encouraging change. In this environment, motion is no longer directional. There is no flow from one place to another, only gentle fluctuation. A vibration here, a drift there, each one absorbed seamlessly into the whole. Nothing accumulates, nothing depletes. Space continues to open, but this opening feels more like spaciousness than expansion. There is room everywhere, and no sense of crowding or separation. Distance has become an abstract idea, irrelevant to experience. Time remains present, but without urgency or emphasis. Moments do not follow one another in a way that demands attention. They simply coexist, layered gently, indistinguishable in tone or texture. The remnants that still exist, cooling stellar cores, isolated particles, faint radiation, do not interact often enough to alter the calm. Their presence adds texture without motion, substance without activity. This is a universe where persistence has replaced process, where what exists continues to exist, not because it is sustained by energy flows, but because there is no longer anything driving it to change. As this chapter lingers, it does so without seeking an end point. The stillness it describes does not deepen into silence, nor does it resolve into emptiness. It simply remains open, wide, and unpressured. There is no final page to turn, no closing gesture required. The universe continues in this state, balanced, quiet, and expansive, holding energy without motion, time without milestones, and space without edges. Nothing asks to happen. Everything is already at rest. As this stillness continues, it becomes clear that nothing within the universe is waiting for permission to change. There is no signal to respond to, no imbalance to correct. The conditions that exist are sufficient unto themselves, requiring no adjustment and inviting no interruption. The quiet is not a pause between events. It is the dominant state. What once felt like silence between motions has expanded to fill everything. Motion itself has become a subtle texture rather than an action. Heat remains present as a quiet consistency. It does not travel with purpose or collect in meaningful ways. It exists evenly, supporting only the faintest expressions of movement allowed by the universe's long evolution. Nothing grows warmer. Nothing grows colder in a way that can be felt. In this environment, even randomness feels gentle. The smallest fluctuations arise and fade without consequence, absorbed immediately by the surrounding calm. There are no chains of cause and effect that propagate outward. Each moment is self-contained. Space holds this calm effortlessly. Its openness does not strain or stretch against anything. Expansion continues, but without landmarks, it does not feel like motion. It is simply space allowing more space. Time unfolds similarly. Without milestones, it does not move forward so much as remain present. Moments do not build toward an outcome. They exist quietly alongside one another, indistinguishable in character. The universe has entered a phase where continuation itself is the only activity. Not growth, not decline, simply persistence. What remains, faint radiation, dispersed matter, distant remnants, occupies this vastness without interaction. Their presence adds depth without disturbance, substance without urgency. There is no tension here. Nothing presses against anything else. The universe has resolved its differences not through force, but through patience. Chapter 3 stays within this resolution, allowing the calm to extend without boundary or conclusion. The stillness does not deepen into absence, nor does it require a final word. it simply remains.